Okay, I just wanted to spend a little bit of time looking at writing formulas for ionic compounds, and I've got a few examples on the board for you to see. First of all, just to kind of go over the naming of ionic formulas, you'll notice that the cation is always written first in the formula. The cation is the positively charged ion, and then you have the negatively charged anion written second. The first one is capitalized, the second one is not. Also, look at the anion. They have changed the ending. What used to be chlorine is now chloride. So when writing these formulas for ionic compounds, you do change the ending of your anion to IDE. Oxygen, what used to be oxygen is now oxide. So be sure to note that. Now, we're going to start by writing some of these formulas. Looking at the first one, magnesium chloride. First thing you want to do is find the different elements on the periodic table and determine what charge those elements are going to have when they form an ion. Magnesium, you'll note, is in group 2 of the periodic table, and those in group 2 form a positively charged ion, and they are at +2. Grab my pencil. A +2. Chlorine is in group 17, and those in group 17 need to gain an electron, so they actually form a -1 charge. Now, what the point of this is to get these to balance. 2 minus 1 does not equal 0, and I want those to equal 0. I want this to be a balanced compound. So what can I do to these in order to get them balanced? Well, I can multiply the chlorine. I can have 2 chlorines. And if I have 2 chlorines, I get an overall charge. -1 times 2 is -2. And if I have 1 magnesium, I have a +2 charge. +2 minus 2 gives me an overall 0. And that's the point of this. What you want to look at is how many of these atoms did I have? What did I multiply by? Those two things are the big numbers that I need to write this formula. So I'm going to start by writing the symbol for magnesium, Mg. There was only 1 magnesium. I do not have to put a 1 here. It's given. So I'm going to leave that 1 off. Then I'm going to write chlorine symbol, Cl. And there are 2 chlorines, so I'm going to write that in the subscript position. So now I have MgCl2. There's 2 chlorines, 1 magnesium to balance that out. Okay? You can pause now and try to do these other 2, and then I will go over them. But I'm just going to go ahead now. So lithium, find that on the periodic table. It's in group 1, so it has a +1 charge. Bromine, over in group 17, has a -1 charge. Well, those are already balanced. If I have 1 lithium, I'll get a +1, and if I have 1 bromine, I'll have a -1. Those balance. So to write this formula, it's going to be lithium symbol, Li, bromine symbol, Br, and that's it, LiBr. Okay, the next one on our list is iron 3 oxide. Notice that iron is one of these transition metals. The only way to determine what their charge is to look at what's in parentheses here. If you have a Roman numeral 3, that means that iron carries a +3 charge. Go on the chart and find oxygen. Oxygen is in group 16. It carries a -2 charge when it forms an ion. So we've got a little different situation here. How can I get these to balance? Well, if I get 6 out of both of them, I can multiply them by the opposite number and get 6 out of both of them. And that's going to be the quickest way to get these balanced. So I'm going to take the 2 and multiply, I'm going to take the 3 and multiply it by 2. And I'm going to take the -2 and multiply it by 3 atoms of oxygen. In this case, I get a +6. In this case, I get a -6. And those give me a 0. So we're looking at the number of atoms that we had to multiply by to write our formula. Iron symbol is Fe. And I have 2 irons. Oxygen is O. And I had 3 oxygens. So it's going to be written Fe subscript 2, O subscript 3. And that's just a little information on how to write these. We're going to work some more in live class on Thursday. So join me then, and then I will open up that test or the quiz. So email me if you have any questions about this.